All right, so now we're going to have two hypotheses. And we need to graph it so it represents both of them. So I hypothesize that there will be a main effect for seating location, such that students in the front will have higher grades than students in the back. I also hypothesize that there will be a main effect for time of day, such that students in the 9 a.m. class will have higher grades than students in the 3 p.m. class. So what we're arguing here is that there are two main effects but no interaction. So the key here is to make sure that your graph represents both of these main effects, but that it also doesn't represent an interaction. All right? So pause the video for a second. See if you can graph this out. I know it's a little bit tricky, but take a minute. Try to see if you can graph out whether you have this particular main effect for seating location and this other specific main effect for time of day. And again, the graph has to represent all four conditions and represent both of these main effects and not represent the interaction. So don't move forward until you've at least attempted to graph this. So hopefully your graph looks something like this if you did a line graph. So if you look carefully, what you can see here is that the average of our fronts, right? So the average, so the 9 a.m. in the front is at 95. The 3 p.m. in the front is at, I guess that's 75. Yes. So that means the average of those is 85, right? The average of our backs is going to be 70 and 50. So the average of that is 60. So 85 is higher than 60. So therefore, we can say that we have a main effect of seating location, such that those in the front, m equals 85, were higher than those in the back, m equals 60. Okay. Now, to represent the main effect of time of day, you take the average of your 9 o'clocks. So the 9 o'clock in the front, again, is at 95. 9 o'clock in the back is at 70. So 95 and 70 put you at like 82.5, something like that there, right? So this would be the average of our 9 o'clock class. For our 3 o'clock class, we're averaging, this looks like 75 and 50. So that puts us to like 62.5, right? So we had 82.5 and 62.5. So because those are different, we can say we have a main effect of time of day. So that students in the 9 o'clock class, m equals 82.5, had higher grades than students in the 3 o'clock class, m equals 62.5. So again, we're just taking the average of our 9 o'clocks and comparing it to the average of our 3 o'clocks. If we're looking at seating location, we're taking the average of our fronts, right, and comparing it to the average of our backs. So this graph represents two main effects, no interaction. If we had a bar graph, it would look like this. So that we take the average of our, if we're looking for a main effect of seating location, we take the average of our two red bars, which are the fronts, right, and that would give us 82.5, and we compare it to the average of our two bars for the back, which are blue, which was 82.5, and then we could say we had a main effect of seating location such that students in the front, m equals 82.5, had higher grades than students in the back, m equals 62.5. If we're looking for a main effect of time of day, we're taking the average of our 9 o'clock. So again, the average of the 95 and the average of the, I forget what this was, 70, I guess, right? And then we're going to compare that to the average of our 3 o'clocks, right? So it's always looking at the averages when we're talking about main effects. And because those averages are different, we can say we had a main effect of time of day such that students in the front had higher grades than, students at 9 o'clock had higher grades than students at 3 o'clock. All right. So now we're moving on to more complicated ones. We started out with the easier ones. This one, we're looking at two main effects and an interaction. So I hypothesize that there will be a main effect for time of day such that students in the 9 a.m. class will have higher grades than students in the 3 p.m. class. I also hypothesize there will be a main effect of seating location such that students in the front will have higher grades than students in the back. Finally, I hypothesize a time of day by seating location interaction, such that at 9 o'clock, at the 9 o'clock class, students in the front will have higher grades than students in the back, but at 3 o'clock, there will be no differences between students in the front and students in the back. It's a lot. So two main effects and an interaction. The line graph and the bar graph that you create have to represent all of that. Now, my advice is that when you have interactions and main effects, start by trying to make sense of the interaction, right? So the interaction is that students at 9 o'clock, those in the front will have higher grades than those in the back. But at 3 o'clock, there's no differences, right? So start by trying to make sense of that, and then factor in that on average, the 9 o'clock class has higher grades than the 3 o'clock class. And then on average, students in the front will have higher grades than students in the back. But start by making sense of the interaction and trying to graph that, and then factor in the main effects. I personally find that to be easier. If you start with the main effects and then factor in the interaction, you're going to get lost. Right? It's almost inevitable. All right, so take a minute, pause the video, and see if you can make sense of this interaction. Hopefully you got something along this lines. So as you can see here, at 9 o'clock, students in the front had higher grades than students in the back. That's what the interaction said. At 3 o'clock, there are no differences. So that represents that part of it. We also said we had a main effect of time of day, right? So the average of our 9 o'clocks, which would be about, 70, is it 90 and 65? So like 70 something, right? Is higher than the average of our 3 o'clocks, which is at 65. We also have to make sure we had our main effect of seating location. So the average of our fronts, which would be about 75 or so, was higher than the average of our backs, which is at 65. So this particular graph shows that we have both the main effects that we predicted and the specific interaction that we predicted. If you have a bar graph, it would look like this. Again, it would show that at 9 o'clock, front is doing better than back, but at 3 o'clock, they're doing the same. It also indicates that those in the 9 o'clock class, on average, are doing better than the 3 o'clock class. And on average, those in the front, the two red bars, are doing better than those in the back, represented by the average of our two blue bars.